Okay, so let's talk about naming amides. So naming amides is similar to when you are naming an ester. So in order to kind of go over that, we'll talk about the reaction first. So the reactions that amides do are pretty much identical to the reaction that happens when we create an ester. The only difference is instead of needing an alcohol, we have ammonia. So we have ethanoic acid, so you need a carboxylic acid, okay, and you need something with an amine on it. Okay, so this can be actually even ammonia. So it can be something with a nitrogen, essentially. You need either an amine or an ammonia group, something that has a nitrogen, but you do need at least one hydrogen on it. So tertiary amines would not be able to do this. So even if you look up here, it's ammonia, a primary, or a secondary amine. You cannot do this with a tertiary because you must have a hydrogen on there. So what ends up happening? The OH from the carboxylic acid and one of the hydrogens that's on that nitrogen come together to make water. And the nitrogen group will link up to the carbon on the section where you had your OH group from the carboxylic acid. So that's why you end up having the nitrogen being right beside the C double bond O. So when you are looking at this, this is essentially, it can be called a whole bunch of different reactions. So sometimes you'll see this be called a condensation reaction, a dehydration reaction. They mean the same thing. Essentially, you're producing water. You're removing a water from the OH and H here. So for naming them, the parent name is amide. So amide itself. And then, of course, the parent, just like when you had an ester, it's always the portion where you have the C double bond O. Okay, so let's say we had something that's larger. Okay, for the naming. And I'm going to have something on this nitrogen group. Okay, so here we have our parent, right, is always the portion where your C double bond O is. So the one that derived from the carboxylic acid. So this is going to be butanamide. Oh boy, do I have exactly the same example that I have over here? Yep. Okay, let me just double check. Yes, that's a methyl. Okay, sorry, pardon me. So butanamide is the parent. We have an ethyl group that is on this nitrogen. So see how over here the nitrogen had nothing on it? So it was just ethanamide. Just like with everything else, if there is something else on that nitrogen, you will have to indicate that. So here we have an ethyl. So this will be N-ethyl. Okay. And just like with an ester, there is a space in the name. There is also a space in an amide. So everything that is before the space is essentially what is attached to the nitrogen. Everything that is after the space is what was attached to the original carboxylic acid. Okay, so the butanamide part is from the carboxylic acid. The ethyl portion is what was from the original amine before it attached. Now, technically, because of the way that naming structures are in the amides, the N can or cannot be there. It means the same thing. Because everything that is before the space automatically means what is on this nitrogen, you can have the N there, or you may not need it. You can just say ethyl. It's automatically known that that is on the nitrogen. But if you want to keep it consistent, I would suggest to keep the capital N. Your textbook does keep the capital N anyways. But in case you come across something or on a worksheet or in online somewhere, if you're looking, if you see an amide without the N, it's because it's automatically assumed. Okay, so this is just a comparison part here. I was gonna say slide, but this is just a comparison of the ester reaction to the amide reaction, and just to show you how similar it is. All right, so here you have a carboxylic acid. Here you have the alcohol. So remember, the OH from the acid and the hydrogen on the OH from the alcohol are removed to make water. And then the portion that was on that alcohol will link up to where the OH was removed. So here you have methyl space butanoate. So in front of the space, it's whatever was on the original alcohol. The parent is always the carboxylic acid. So same thing happening here. The carboxylic acid OH and a hydrogen on the nitrogen group become water. And then what ends up happening is the nitrogen will link up to where the OH was removed. So here you have butanamide, right? This is the parent. And then in front of the space, we have a methyl. So here you have N-methyl. But remember, even just saying methyl butanamide, it is assumed that that is on the nitrogen. So we've already mentioned kind of the naming system and how to name them. So let's take a look at these two examples here. So remember, the parent is always the same. It's where the double bond O portion is. So here we have two different carbon groups. So it's in front of the space. If you notice, there is a space there. There are spaces here. So butanamide was the carboxylic acid originally. On the nitrogen, there is a methyl and an ethyl. This is in alpha order, just like you would any other branch. Okay, over here, if you happen to have the same one, this is actually a good point to bring up. Remember I mentioned the capital N almost acts the same way as a number would. So just like if you had two branches on the same carbon, you would need double the number, like 2,2-dimethyl or diethyl, whatever it is. You would need the same thing if you have multiples of the same branch on the nitrogen. So here we have two of the same groupings. We have two ethyls. So it'd be N-diethyl. So these are basically saying both of those ethyls are on the nitrogen themselves. Okay, so that's it for this portion here. This will actually be the end of our functional groups, as I mentioned. So please stay tuned, and if you have any questions, you can always let me know. Send me an email, okay? I'll see you later. Bye-bye.